Welcome back to Building HVAC Science. In this episode, my co-host, Eric Kaiser, takes the reins. I was absent for the recording, but he did a great job in handling a conversation with our three guests, Linda Wigington, Bill Collinge, and Rhett Major. The discussion topic is ROCIS, and that's not like noisy, unruly kind of ROCIS. It's ROCIS, which stands for the reduction or reducing outdoor contaminants in indoor spaces. Linda's been working on this project for 10 years to help participants in this citizen science, this self-monitoring program, improve indoor air quality, particularly in areas with poor outdoor air. Now, it's primarily focused in southwestern PA, that's near Pittsburgh and south and west of that, but it includes virtual cohorts where participants use some of these low-cost monitors to track air quality and receive guidance on how to improve it. It's a really interesting conversation. Got some great links in the show notes to the people, Linda, Rhett, and Bill, as well as their Facebook group and the website, rocis.org. Please take a listen into this episode. Pay attention to some of the details about breathing easy, tackling outdoor contaminants in indoor spaces.
Hello, everyone. Welcome back to another episode of the Building HVAC Science podcast. Eric Kaiser here. Bill Spohn is not in the studio today. He's out doing some other things, but we have three special guests from the ROCIS team. Linda Wigington, Bill Collinge, and Rhett Major are here with me today. Welcome, everyone. Linda, start us off. Tell us a little bit about what ROCIS is and what you're doing with the program.
ROCIS, Reducing Outdoor Contaminants in Indoor Spaces, is in its 10th year, and the primary activity we're involved in is the low-cost monitoring project. That's where we spend most of our team time and effort. And we're about to start, probably by the time this is shared, we'll have started our 61st cohort. So we've had over 500 folks participating, borrowing equipment for a month, and then participating. It's a virtual cohort, so folks participate in online meetings, and Bill Collinge provides weekly feedback, and we really help people understand the opportunities to improve their indoor air quality.
Nice. And that's my fault for mispronouncing things here. So ROCIS, is this a local organization, national organization? How do you find the people that participate and identify them and then get them into that program?
I like to think of ourselves as an initiative, as we're not a nonprofit. We are funded by the Heinz Endowments, and our focus is on southwestern Pennsylvania. But because we have virtual cohorts and we've got contacts all over, we certainly want to have impact outside of Western Pennsylvania, and we want to get the benefit of wisdom from outside Pennsylvania as well. So our participation in our cohorts is usually open to a couple people outside of Western Pennsylvania, and the rest of the folks that are participating are usually in mostly southwestern Pennsylvania.
So southwestern Pennsylvania primarily, but then you'll open it up around the country to a few other people. When you're looking for this, let's step back a little bit farther. How did you get this whole program kicked off? What was the beginning of the program for you?
The ROCIS initiative started with a very clear question, and that was, what can people do if they live near a pollution source or in an area with poor air quality and they don't want to relocate? The impetus for ROCIS, Reducing Outdoor Contaminants in Indoor Spaces, was looking at soil, water, and air, and looking at what the options were for people living here and liking it here other than those issues. So that then led to a couple of white papers, and it led to a effort bringing in a number of parties from academia, nonprofit organizations dealing with housing, energy, affordability, health, as well as private individuals working across the sustainability spectrum. So bringing all those folks together and establishing and clarifying the fact that outdoor pollutants can have a significant impact on indoor spaces. And that's widely understood now, but 10 years ago, that wasn't nearly as widely appreciated in terms of the impact of outdoor on indoor. Out of that process involving lots of folks in different meetings, 2 white papers, presentations, there emerged a focus because that area is very broad. So we really started focusing much more on particles or PM 2.5, and then we also and radon and using low-cost monitoring in order to provide feedback, knowing that our monitors are limited in what they can see and tell, and there's a lot of stuff important that our monitors don't capture. But the idea is that these monitors can provide very useful information in order to improve one's indoor air. So that led to, initially, when we decided to do some cohorts, we thought we'd do it for a year or two just to see what we could learn, with the idea that people who participated could then figure out how they want to use monitoring within their organizations. But we've not found that we've run out of opportunity to engage people in a process to really learn about their air quality and whether the impact is primarily as individuals or as somebody active in their neighborhood or community, or folks whose profession involves areas related to what we're doing at all. We've got participants across the board. But we found that the cohort model works well, and 1 month of monitoring works well.
Interesting. That leads me to a whole bunch of questions because I've done a fair bit of experimenting, as somebody may have heard in a previous episode, and Bill and I have both done a lot in our own houses, just playing around with different things. And I think I might want to throw this question over to Bill here. I got too many Bills, just realized we got multiple Bills. Bill Spone and I have done a lot of playing with our own houses and testing with our own monitors. Bill Collinge, I want to ask you, because your job is really an air quality analyst, what do you see different in a lot of the low-cost monitors that we get in houses versus maybe some more higher-end laboratory-grade instruments?
Well, I think the primary difference is the type of pollutants that we can measure. So with the low-cost monitors, the ones that we're using right now, as Linda said, we do have radon, we have carbon monoxide, although that's a little bit less of a focus because we don't see a lot of it. But besides radon, I think that the biggest two things we have are particles and carbon dioxide. And both of those are ones that can be measured with relatively inexpensive equipment. Particles obviously have indoor and outdoor sources. Carbon dioxide is primarily, although not exclusively, a function of occupancy and building tightness. So we try to use those two measurements to paint a picture of the air exchange of any individual house with the outdoors, and whether or not there's much in the way of filtration going on and whether there's adequate ventilation. And as you know, if carbon dioxide is high and it doesn't seem like there's adequate ventilation, then that's reason to think that there might be other issues associated with other indoor pollutants that aren't getting ventilated, but which we don't have the technology to monitor. So high quality lab monitors, you can get a lot more different types of things like individual VOC species and so on that we really can't determine with low cost monitoring, although that's becoming more of a thing these days. And it certainly wasn't when we started out. So we focus on a few key markers, and we hope to be able to use those and interpret those to not only calculate folks' exposure to outdoor particulate matter, that's really one of the big metrics, but to also characterize the indoor environment in terms of interplay with the outdoors, if that makes sense.
So when you set up a monitoring at someone's house that's in this cohort, what does that look like? What kind of monitors or how many monitors are you putting together there? Just something indoors, or are you actually looking at the outdoors as well to compare?
We have a total of, I think it's 9 monitors up right now that we're giving folks. 3 of them are particle counters. And what we do is place one of those outdoors in some sheltered location, usually a porch or something if folks have a porch, and then 2 indoors. One's usually in the general living area, one's in a bedroom. So we obviously use the outdoor one as a reference monitor for outdoor particle levels. The other monitors are all indoor monitors. We have 2 for radon, 1 for carbon monoxide, and 2 for carbon dioxide, although up till now, we've only really used one of those in a recording mode. But I think to try to answer your basic question, we measure outdoor particles, and we definitely throughout the cohort process try to relate what we see in folks' indoor particle data to the outdoor particles. We also look at, if we have people located near to each other geographically, their outdoor particles in comparison with each other to see how they vary and to check for any potential local issues or data errors.
That's always great to see. From my aspect, I like to see a lot of comparison data on things like that, where, and especially if you've got people close by, that's a neat way to be able to do that and to bring people into the groups.
I mean, one of the things we've worked a lot on is to provide data visualization systems to look at our data in different ways and let people compare with each other. And one of the tools we have, it is a digraph, a time series graph showing everyone's outdoor plot by neighborhood. Obviously, some of the folks outside the region can make that a little messy. But the thing that has always surprised our participants is that I think there's the impression that some folks and where you live might absolutely drive your pollution way, way high. And if you happen to live high on a hill on the other side of town, you're in a safe neighborhood. And while there's obviously differences between the different sites, and part of the limitation is what our monitors can measure, because they can't really pick up some of the things that make the particles as toxic as they are. People are always surprised to see that we're all in the same airshed, and that when the outdoor air gets really good, just due to some fluke of wind and dispersion, it's good all over the place. And when it's bad all over the place. So even though there are differences, that I think has really been a very important thing that people have learned, because it makes you realize that we need cleaner air and we need to recognize that we're all affected as well.
That is a super interesting observation. You're talking about a hill across town, so that would be an altitude or an elevation gain or change like that. But yeah, air currents and things like that, I can see where that would affect a lot more people, and possibly the assumption that, yeah, so if I'm above that pollution, maybe I might not be affected by it as much. Now, what kind of, you said graphs, are you using just graphs, or are you actually visualizing this on maps in real time or historically after the fact?
We haven't done any visualization that actually takes this precise neighborhood over long term. The primary, and Bill has been doing on Excel, as well as what we've done online for all 60 cohorts. We've just identified the neighborhood so you can click and see, okay, for this neighborhood, where's the graph? But the notion of actually animating anything regarding parts of town has not been done. But there are some fantastic tools CMU's Create Lab has done, and there's Smell Pittsburgh. There's another one looking at pollution sources and weather, Plume Pittsburgh. So there are some neat tools for folks in southwestern Pennsylvania to actually see the neighborhoods, but we haven't visualized the neighborhoods within ROCIS.
That's neat. Do you see anything like this expanding around the country? Because I'm assuming that you're tied into other people around the country, that you probably see other programs like this maybe popping up in different places, or is ROCIS still a unique organization?
I think the primary thing we see in terms of impact beyond what we're doing is that others are learning from what we're learning in terms of particularly filtration and the air handler intervention work that Rhett has done. But the actual cohort process is pretty labor intensive and pretty unique to having funding from the Heinz endowments. We are interested in finding folks who would be interested in exploring how we could clone or support other initiatives so that others wouldn't have to do all the legwork that we've done to get to the point where we are. But it's pretty labor intensive endeavor.
It sounds like it could be to collect all that data and organize everything. You mentioned something in there that Rhett's been working on. We haven't talked to Rhett a lot so far. Tell us about your air handler work here, Rhett, a little bit about what's going on with that.
After someone has been through the cohort, then Linda sends out an email and asks if they're interested in having their system tested to see if it's good candidate for 24/7 filtration. So I'll go into the home. Bill's been accompanying me with this lately. I'll go into the home and I'll test static pressure in the system. I'll put a current transformer with a little energy monitor right on their HVAC system to see how much wattage the fan is drawing, so that if they're going to use their fan to clean their air, to clean particles out of their air with their filter, we want to make sure it's set up so that they have a good filter, low wattage draw, and it's not taxing the system. It's easy to say, but hard to figure out. So I'll spend 2 hours or more in a home testing a system, testing different aspects of it, trying to figure out if that's a good system to encourage people to go ahead and use it. And so I will do that. I just sent out a report this morning from a system we looked at last week where I can encourage them to go ahead and use the system in that fashion. Sometimes we'll even install thermostats that allows it to run 50% of the time, like an Ecobee or a Nest. So I've installed a number of Ecobees for furnaces that will run 50% or 30% or whatever, if they're a good candidate, I should say. If they're a good candidate for intervention, then I measure the system up to try to replace primarily the return system with a good filter box in it. I like Honeywell and I like Aprilaire. They're both very good filters for MERV 13 filtration. We try to set them up in the most advantageous position so that they get the best airflow down and through the filter, and it taxes the system as little as possible. There's different types of motors in furnaces and air handlers that different motors are more sensitive to the static pressure or the drag in the system. So I'm measuring the static pressure. If I'm intervening, I'm trying to reduce that static pressure. I'm trying to put in the best wide, long-lasting filter that we can, and then encouraging people as how to use it to best filter their air.
Very nice. And that's a really big thing. Static pressure reduction is, of course, going to be wattage reduction overall on that blower motor and overall energy usage reduction. Have you tracked any before and after wattage or energy usage on these to see if there's been an advantage just by putting that filter in? I'm assuming probably a couple duct modifications have to be done by putting those in as well. So
we have tracked, mostly it's instantaneous measurements that I'm taking versus tracking. But some folks have energy monitors on their home so they can see the difference. But usually I'm taking instantaneous wattage in the various AC, heating mode, and circulation mode. And after my adjustments, again, taking those, or after my interventions, I should say at this point, we're comparing the before to the after. So we can see the relative drop. However, long-term monitoring, very few people, I think, are actually doing the electrical monitoring long-term. We do encourage them to monitor their particles. So a lot of times I'm setting up a purple air monitor in the home after I've intervened, and then they can monitor their progress, or they can try different methods of running their fan in different patterns, let's say. And then they could see how their indoor air quality responds compared to the outdoor air quality. But as far as me monitoring that, no.
So we do have some graphs and information on our website under solutions and then under air handler inquiry. But a lot of the reduction in energy use comes from changing and adjusting the speed of the motors correctly, because many motors aren't going to see an impact just because there's a change in static. But certainly the high-end ECMs is where you see the really big difference in energy use if you've got high static versus low static. But initially, I think the first 60, I think you're probably over 100 now, but in terms of systems we've checked. And originally, we must always found that the air handler wasn't properly, or the furnace wasn't really commissioned in order to have the speed set properly for heating, cooling, and continuous operation. So if somebody ran their air handler continuously, it would kick into the AC mode, which is the highest, and that would be the highest watt draw as well as highest static. We're actually seeing some improvement in that we're seeing more systems are acceptable than we did initially.
That's true. When I'm at my first visit, I am adjusting fan speeds quite often, because when they come from the factory, they're usually set to the highest speeds on the little boards. And that's not always appropriate for each individual AC unit or each individual furnace system. So by measuring temperature rise in the heating and temperature drop in the cooling modes, and measuring the fan CFM, I'm often changing the fan speed to better match the system as it's set up. And when I do that, when I turn the fan speed down, it's automatically going to save energy. Now, there's 3 different kinds of furnace fans that we will run into. The older style permanent split capacitor, it doesn't care about static pressure as much as you would think as far as wattage draw. If you have high static pressure, you won't get airflow that you want, but your wattage draw doesn't change much. It actually goes down a little bit. If you have a constant torque ECM, it's not very sensitive to wattage draw, a little bit. But if you have the constant volume ECM, that's the higher end variable speed furnaces, they are very sensitive to static pressure. And the difference in fan speed settings and static pressure that I measure makes a big difference in the wattage draw. And we have measured systems that were constant volume ECMs that are supposedly energy saving furnaces, but they were using a tremendous amount of wattage because of the restrictions in the system, restrictions in 1-inch filters, restrictions in high fan speeds, or restrictions in the ductwork. And when I'm testing static pressure, I'm pretty much mapping the system so I know where the restrictions are. I'm looking at restrictions in the return, restrictions in the supply, restrictions across the filter, and restrictions across the coil. And so I'm making recommendations based on those individual points in the system to which one's really causing the problem. If there's more than one, of course, I'll point that out too. Now, I can't solve every one of those problems. And a lot of times I'll have to get HVAC techs involved because it's beyond my ability. But most systems I can adjust the fan speed, and with the permission of the customer, I'll do that on my initial visit. When I'm doing a intervention, one of the things that we can do is we put in a constant torque ECM to replace a permanent split capacitor motor. We'll put in a constant torque ECM, and I'm able to adjust the speeds on that new motor so that it best matches the system's needs. I'll test the heat rise and put it in the right area of the range of heat rise, and I'll test the temperature drop in the AC, and I'll put it in the what I believe to be the best area of temperature drop. And usually around here, it's about 350 CFM per ton so that we get more dehumidification in the cooling mode.
So when you're talking about things not being set up right initially, and I kind of want to highlight that because I think we see that on a lot of systems. Are you just saying heating airflow, cooling airflow, the whole 9 yards, nothing is set up properly? What are you seeing most of?
It's mostly the cooling airflow that's whatever the default setting is on the furnace, on the air handler, is generally the highest speed. It comes from the factory in the high tap. And the installers don't know enough or don't care enough to turn it to the correct speed based on the tonnage of the outdoor coil. And it's generally a simple selection, and I can figure it out. I'll download the instructions for each furnace before I go there, and I'll figure out what the appropriate fan speeds are and how to change them so that when I'm there, I can generally offer that change out to the customer. Once I've tested initially and seen that the static pressure is high, the fan speed's high, the watt draw is high, then I'll suggest to the customer, and with their permission, I'll turn it down to the appropriate speed. And then again, retest static pressure, wattage draw, airflow. And generally, I'm happy with that. Sometimes I have to adjust them back up because of certain issues in the system, with especially heat rise. If you get your heat rise too high, you shut the system off on high limit. So there's a band that I've got to keep within on how much CFM per ton or how much CFM per 10,000 BTUs. And we'll remeasure and not just take it for granted that what I've done is correct. I'll always remeasure what I've done.
Nice. Are you using any specialized tools to do this measuring, or is it pretty everyday stuff that a lot of technicians are going to have?
Well, the watt meter we use the OWL, OWL There's lots of examples out there of watt meters that you can use, and you're basically putting a clamp over a black line in the furnace and then closing the door. So you can't use your handheld. It has to be something with remote capabilities. And then I'll have the monitor will sit on top of the furnace, and then I can watch the wattage change as the speeds change. I'm using standard static pressure probes and digital manometers that anyone in the industry, whether they're doing duct leakage testing or blower door testing, they'll have a manometer that's that accurate. A lot of your standard HVAC techs have been using manometers that are not precise enough to get these measurements that we need. They're very precise. We use pascals, which is 250 pascals in an inch of water column. If you're using the old analog meters, they're probably not sensitive enough to see the differences in static pressure as much as we want. And then I'm using a meat thermometer to test heat rise, although I do have a few fairly sophisticated HVAC tools to measure that and to measure the dehumidification. A lot of times just that meat thermometer is telling me everything I need to know. I'm putting it in the appropriate return hole in the appropriate supply hole, and I'm getting able to test the heat rise accurately and the temperature drop accurately. Sensible temperature drop. I'm not always measuring the latent drop, and takes a little more time to do that. I don't often do that.
We're seeing some great leadership and training efforts and tools being developed like Measure Quick to make it easier for the contractor to commission a system once it's installed. And it's just so important that there be recognition that you got to select a system, ideally, that's not way oversized. If it's way oversized, typically your ductwork's undersized, and that's a critical problem. But then also that the system needs to be commissioned. It just needs to be checked. And if you don't, when you think of all the systems that are going in, whether they're high-end systems or the lower-end systems, it's a tremendous wasted opportunity if they're not done right. We've saw several relatively new systems go in with the constant torque ECM that because they were oversized, we could not get that to be performing as well as the system that it replaced. So that's a real irony when you consider the fact that the whole idea is get rid of all these old permanent split capacitors and go with ECMs, but the constant torque ECM might not give you the settings that you want. And particularly if you oversize it, you're going to have much higher airflow necessarily than you'd ever want in a continuous mode. If it's higher airflow, nobody's going to like it because it's going to make them cold if you run it more than when the heat's on or the cooling's on. So lots of things are tied together. And one of the things we have not accomplished, but it's a major goal, is to train to work in collaboration with other folks and train folks, particularly in southwestern Pennsylvania, HVAC contractors, to increase the number of jobs that are done well so that the option exists for filtration. Because normally an HVAC system is not run, the air handlers only run 15% of the time over the course of the year. So even with a really efficient filter, that's not going to make much difference. And you need that runtime to be higher in order to impact the particles in the space, which not just particles, but also diseases are part of that particle load. So it's a tremendous opportunity to at least have the flexibility for healthier housing if it's done well, and a major missed opportunity when it's not.
Very nice. After the monitoring cohort, after an air handler intervention, what kind of reduction are people seeing in the particulates or things in their space from measuring?
All depends on where they start. We do have a chart just like with our first 10 jobs that we did. So that was data from a few years ago, but we were typically seeing 50 to 90% reduction in particles for those specific cases. But obviously, if you already are starting from a good place with fairly low particles on a 24/7 hour basis, you're not going to see as much reduction. But we refer to air quality in a very general way in terms of looking at particles in the green versus particles in the red. Particles in the red would be using the Dylos scale of being poor, very poor, and green would be good, very good, or excellent. And usually we can get houses to spend most of the time in terms of the particle load in the green. Now that's not a third-party rating system, but it's a rating system we've applied to data across 500 houses, and we can definitely see substantial improvement. Some of the folks have found that the best way to do things is to run the air handler 24/7 and still add one or two portable air cleaners to hit a home run and really get the particle load really low in bedrooms. But there are some presentations on our website too, so you could see graphs and a couple case studies there.
So beyond that, you've seen this reduction in particulate load. Have you been able to translate that into any positive outcomes for the occupants, like health or anything like that?
We have, for the sake of HIPAA privacy issues, we have definitely avoided asking health-related questions, but we often get anecdotal information. So people will say things like, oh, my allergies cleared up, or I was able to sleep better. We often know that if you do run an air handler a little more or 24/7, you can often compensate very well for differences in comfort between a first and second level of a house. But you'd want to do that on a low speed. As I said, you don't want to run an air handler on a higher speed when there's no call for heating or cooling because you run into comfort issues. So that's why for what we're doing, they go hand in hand. But we often have heard the anecdotal information, but we have not tracked that. We know that because in some cases we're running the AC longer, if you set the air on a lower CFM, then in theory you should also be getting better dehumidification, because you really can't get good dehumidification with the airflow super high and the thing cycling on and off real quickly. But that's where so much of this, and that's part of what Rhett does when he does a visit, is oftentimes if the system's an older system, he'll give people recommendations of, hey, when you replace this system, this AC system, do not put in a 5-ton system. This is way oversized. You'll be so much better off. So it's a really neat opportunity to be proactive in trying to get people to realize that bigger is not better, and you're not going to get higher levels of comfort, energy costs, filtration, if your system is much bigger than the ducts can handle and too big to begin with.
Yeah, if it's too big for the ducts and or too big for the house, it's probably not going to work real well for comfort and or overall performance for sure. Seems to be a big problem around the country where we all think that bigger is better, and not always. And I'll throw this out to all three of you. Where do you see these going in the future? You've got some good programs. Do you see this growing, morphing into something else, getting bigger?
Personally, I'm trying to teach people in other regions, primarily through conferences, trying to teach the principles of what we're doing and teach the retrofit strategies that I'm following. And I'm doing my best to get others excited about it and perhaps involved in their areas. And as Linda said, it hasn't been very successful in our area to get someone in the HVAC realm involved. We tend to scare them away. Seems like they just want to change out boxes. We're always looking for HVAC candidates that want to learn these principles. We'd love to hear from you. We have a lot of information on the website that shows what we're doing in the intervention process. And of course, the tests that I do when I'm in the home, those are something that I present at conferences. And you'll see some of that in the ROCIS videos that Linda mentioned. And someone that wants to learn more about this should certainly contact us if they have an interest to understand the interventions that we do, or of course, the tests that we take.
I think there's a tendency for people to think that the solutions are just technical fixes, and really achieving a healthier house, better air quality is a function of a pretty active, a knowledgeable participant, as well as support from knowledgeable, motivated trades and helping them get and choose and invest in the right kinds of things. So it is interesting that at the beginning of a cohort, we're seeing more and more people who already have portable air cleaners because they were very cautious during COVID and they assumed that an air cleaner would help. But what we're also seeing, interestingly, is oftentimes, more often than not, air cleaners aren't being run in a setting that allows them to get the maximum gain. A lot of the air cleaners have an automatic setting that basically is great for saving energy, but it only kicks the air cleaner on if you're cooking and you burn something. So oftentimes we advocate for how people operate the equipment they've got. So rather than expand the cohort to try to get more people into a cohort, we're really looking for opportunities to share what we've seen and learned in terms of the kinds of things you can do to reduce creating particles in the first place, misconceptions regarding the fact that outdoor air is not necessarily cleaner than indoor air. And particularly in Pittsburgh, at night, it's often worse at night. And that's when people like to open the windows the most. And then the issue of just, hey, if you've got an exhaust hood and it's vented to the outside, it only is working if it's on, and you need to be operating it. So the monitoring equipment we have provides a really good proof of that. The question of whether or not and how you can carry the message and lessons learned unless somebody has the direct experience and the feedback and the interpretation is a little bit challenging. We'd welcome opportunities to talk to folks who are listening to this podcast about ways to, beyond the energy, the recommendations, how to expand the impact of the things we've learned and the integration of both providing feedback to folks as well as the knowledge of the interaction of how we operate our homes and what systems we have in it.
Bill, you want to add anything onto that?
I don't know. I thought Linda and Rhett did a good job of covering it. I'm fairly new on board with ROCIS, although I've been involved in the past long ago, back towards the beginning, and now I am again. I'm just hoping that maybe we can start to dig a little bit more into the data, the historical data that we have, and look for some more patterns and look for better ways that we can inform folks as to what's happening. Maybe come up with some models, different models for indoor particles based on outdoor, and integrate CO2 in there and look at trade-offs between ventilation and filtration, or really you need to have both, so it's not so much of a trade-off if you do it correctly, but looking at the existing trade-offs that people have prior to interventions between ventilation and filtration, and then looking at try to quantify the impact of the interventions that we do.
Very cool. We're getting close to the end of where we'll close the show out here. So I want to go around the room real quick and just ask each one of you for any final thoughts or final wisdom that you might have for our listeners out there. Rhett, you want to kick it off?
Yes. Given a choice, the wider the filter that you are able to choose, generally the less static pressure draw and the longer it will last. These 1-inch filters they keep putting into furnaces are the most restrictive and have to be changed the most often, whereas the 4-inch filters, which offer a lot more surface area, a 4 or 5 or even 6-inch filters, some of these air cleaners, they use better technology, they're less restrictive, draw less wattage from your motor, and they'll last sometimes 6 months, sometimes perhaps as long as a year. And the way people neglect their filters anyway, it makes sense for us, especially in weatherization and in some of the programs where the public sector is paying for this to be done. It makes much more sense to put in wide filters that will last a good long time than the skinny filters that must be replaced every 30, 60 days.
Very nice. Bill, how about you?
Well, I'd like to say, as a person who likes to open my windows whenever I can, right? I like that feeling. I feel like that's good for my mental health. To be connected to the outside, even though I live in an urban area. I would just encourage people to, if you can afford it, or if you could join a program or something like ROCIS, get yourself an outdoor air quality monitor. Some probably particles is the most obvious choice, whether it's purple air or Dylos or something else. And take a look at that thing before you open your windows and pick and choose the days when the air quality is actually good outside. That's what I'd recommend.
Sounds like a good idea to me. I'm looking at some of the things that happen in outdoors. Makes me wonder if maybe we should spend more time indoors, but I don't know about that all the time. Anyway, Linda, I'm going to turn this over to you, and I want to ask you also one other thing. Where can people find out more about this in addition to your final thoughts?
Okay, I'll answer the second first, and that is rocis.org is our website, ROCIS.org. And we also have ROCIS videos on YouTube, so that you can go to our YouTube channel as well. The thing that you could have misinterpreted from what Bill said was that indoors is protective if you've got the windows closed. And yet what we often see is that even though it's a fraction of the outdoor particles when the outdoors are really bad, our indoors is still very much affected by what's going on outdoors, even in a house where things are closed. So filtration is a slam dunk. It absolutely, if it's on, has the potential to greatly reduce particle loads. And there's no aspect of air quality that's been better researched, more thoroughly researched across the world than the health impacts of particulate matter. So there's a huge opportunity to greatly reduce particle exposure. And with particle exposure, because particles often carry other stuff, they have the potential to carry other hazardous things that we're not measuring into the bloodstream and across the blood-brain barrier. So it just makes sense to use the precautionary principle and try to get particles as low as possible and have feedback so you know what's working. We didn't touch on radon though, so Eric, I'm going to hit 2 points here. One is that we do measure radon both upstairs and downstairs. In Allegheny County in general, you see about 4 out of 10 people having radon above 4.0, which is the EPA guideline. In our cohorts, we've seen about 33% of our participants have radon that's above 4.0. But ironically, we asked the question, have you already tested your house for radon previously? And we thought that the folks who had tested their house for radon previously would have lower radon because they're folks that sometimes have radon mitigation systems, for one thing. And ironically, the exact same percent of folks had elevated radon, regardless of whether or not they'd previously tested for radon. So the lesson there is if you're concerned about radon, and you should be, it's something that's relatively easy to manage to drop way down. Don't assume that if the house was tested 5, 10, 20 years ago with a 2 to 3 day test, that holds true. It really makes sense to monitor for radon and just nail that hazard as much as you can.
Some words of wisdom there for sure. And I can say from monitoring radon in my own house, it changes often. It's not a constant or consistent level. So thank you for that as well there. I think that's about all the time we have for this episode. I want to thank Linda, Rhett, and Bill for coming on today, and all of you out there for listening. Until next time, thanks.
Thank you.
Thank you.
Thanks.
We appreciate you listening to this episode of the Building HVAC Science podcast, where Eric interviews Linda, Rhett, and Bill and talks about these outdoor contaminants getting into indoor spaces and in measurements. Hopefully you like measurements because Eric and I both love measurements. You should listen to one of our older podcasts just a few weeks ago where we talked about monitoring madness in our homes. Some of the topics we discuss require technical training for proper interpretation or safe execution. So if you're a trained pro, you can go right ahead. But if you're not, please consult with and hire a trained pro. The Building HVAC Science podcast is a production of TrueTech Tools Limited. In full disclosure, I'm the owner of TrueTech Tools. The opinions voiced are those of my guests, my co-host, or myself, depending on who is speaking, of course. And if you're in the market for any tools or test instruments mentioned in the podcast, and actually some of the products that were mentioned or I learned about through ROCIS are products we now sell at TrueTech, and that probably came up in the conversation. So you can look at TrueTechTools.com, www.truetechtools.com, and you can use the offer code HVACBS for a nice discount. Thanks again for listening to this podcast. We hope you learned something about breathing easy, tackling outdoor contaminants in indoor spaces. Until next time, take care.